Okay, let's try to draw r equals to sine 3 theta. And I'll be quick because I think we've done enough examples. All right, so sine 0 is 0. If you plug in 90, what's sine 3? 3 times 90? 3 times 9 is 270.
270.
Sine 270 is?
-1.
Negative 1. If you plug in 180, 180 times 3 is 540, but that's same as sine 180, so it's 0. And then, what's this? 3 times 27, that's 810. If you do 810 degrees, subtract 720, that's 90 degrees. So this is, if I plug this in, I get 810, which is coterminal with 90 degrees. So you have to do sine 90 degrees, which is positive 1. All right, so let's try to draw that. You get 0, 0. And just let's draw these two lines to remind us that although it's 0, it has to hit the origin at this angle. At 90 degrees, it's negative 1. So if you go up, it's actually, you have to go down by negative 1. So let's say this is negative 1. That's the point that it is. And then 180 degrees, at 180 degrees you get 0 again, so it must be, All right, and then 270 degrees, it's 1. Oh, at 270 degrees you get the same thing again, because at 270 degrees you get the same thing. All right, that's not very helpful.
Just one.
Huh?
Does it just have one?
It's 3.
No, it's going to be 3 petals.
Overall, it's 6.
Okay, it'll be rows of 3 petals. But let's see. Since 3 is multiplied to this theta, let's just think about these angles with 3 divided. Okay, so let's try that. Theta. Divide by 3, so 0 we already did, but 30 degrees. 180 divided by 3 is 60 degrees. 270 divided by 3, I don't like that. Okay. You know what, let's do this. 30, 60, and then, since we already have this, 120, 150, and then, what's the next special angle? After 180, there's 210 and 240. And then 300 and 330. Let's think about these numbers, okay? All right, so if you plug in 30, 30 times 3 is? 30 times 3 is? 90, and sine 90 is? 1. Okay, 60 times 3 is 180, sine 180 is? 0. 120 times 3 is 360, it's 0 again. 150 times 3 is 450, it's 450 is 90 plus 360 is 1. Okay. And then 210 times 3 is 630, which is negative 90 degrees, so it's negative 1. Okay. All right. And then 240, that's 3 times 240, that's 0. 3 times 300, that's 900. What's 900? 900 minus 720, that's 180, so it's 0 again. And then 330 times 3 is 990. If you subtract 720 from it, you get 270. Sine 270 is negative 1. Okay. All right, so we have more data now. Let's see if that helps. So at 30 degrees, I know it's 1 step. We said this is 1, so it's 1 step here. At 60 degrees is 0, so it has to go down here. All right, so that's pretty good because we know that it has to leave the 0 and go positive, and it has to attain 1. And 1 is, by the way, the highest value that this function can have, so that's the farthest distance away, and it has to come back to 0. This is 60 degrees. That's 1 petal. All right, and then in the at 90 degrees it's -1. Right, so I guess this is a little confusing. This should be this. So at 90 degrees it's -1. So after hitting that, coming back, it has to pass through this point. With, again, this being the tangent line here, so it's that. And then at 120 degrees, which is this one, it has to hit 0. And then at 150 degrees, it's 1, so this is 150 degrees, and it has to have this 1 here. So again, making this as the tangent line, it has to go like that. And at 180 degrees, the next side is 180 degrees. You come back like that. So you get the three petal rows at 180 degrees. Now let's continue. After 180 degrees, that's 210. Where's 210? 210 is here. But then you're not going forward by 1, you're going backwards by 1, so you're right here. So at 210, you come back to this. So it looks like it's going through this path twice. Once from 0 to 30 degrees, and again from 0 to 180 degrees to 210 degrees. And then it does this all repeating everything. So if you follow these numbers, it's going to repeat everything. So you still get just 3 petals. Okay. So it's really what's happening is you get rows with 3 petals. But you're going around this rows twice. That's what's happening. So in general, if you have r equals to a times cosine or sine and theta, with n being odd, then you get rows with n petals. So if you want rows with 5 petals, what do you put this n as? 5. If you want rows with 12 petals, what do you put this n as? 6, because if it's so if n is even, we have rows with 2 n petals. So that's what you have to know, and that means it will be impossible to come up with rows with 6 petals this way, because if you want 6, half of 6 is 3, but cosine 3 theta will produce rows with 3 petals, not 6 petals. So 6 will be like the number that it's impossible to produce, okay, using this. Okay. But there are other things which are not called roses, by the way, but there are other shapes that do have something like 6. Mainly we will try to do cardioids and roses first.